On the last day of the conference, and everything's winding down. It looks like they're taking half the conference apart, but we're still here. It's very busy outside, but downstairs it looks quite dead. So my name is Shaun Smith. I'm a product manager with Oracle, working on the Oracle Functions platform and on the FN open source project. I've been in the Java space for some time. I started out as a consultant, but after I left consulting, I came to Oracle, worked on Eclipse Link, so Java persistence, spent a lot of years in the Java E space, and have come, like many of you, to the cloud. And so now I'm working on serverless. And so today, I want to talk about the challenges for Java in the serverless space. And Java gets a lot of bad press in this environment. So if you're not used to, if you haven't seen serverless before, we'll see a bit of serverless. You'll see a little bit of some of the cool things that are in Java. I'm going to talk about things that are in the Java platform, things that some things have been there for years, and some things that are new that really help Java in the cloud space and in serverless in particular. So you've seen the safe harbor many times, I'm sure, this week, so don't make any decisions on things that I'm saying. So just to give you a couple of definitions, so serverless is a broad term. So serverless just means any kind of cloud service where you're not provisioning infrastructure yourself. So I think Larry was on stage this week talking about serverless database, which is basically you don't provision the database, you just say I want some data storage, right? Or even object storage, right? Get into a bucket, you haven't provisioned a server, it's basically serverless. In my case, I'm talking about functions. So functions as a service platform, or a FAS, is basically a compute component of a serverless platform. So when you're dealing with functions or FAS, you deploy your code, you don't provision hardware, you don't worry about the scaling, you just deploy your code, you call the code, it runs somehow magically in the cloud, right? Serverless. And the serverless, of course, there's a lot of people argue about what a dumb name that is. It's true, it's kind of dumb, there are servers, but now the perspective of the user, it's serverless, right? You don't worry about that. The provider, like Oracle or Google or whoever has got all these servers, that's their problem, right? But the user perspective and the user experience is serverless. So in the function space, functions are essentially units of code. They're very small. They do one thing only. Okay, that's the key difference between everything else. Like microservices to serverless, it's really that in a microservices world, you may have a REST API, like a Spring Boot app with a REST API. It does 5 or 6 things. It does, maybe it's a banking transaction app, right? It does deposit, withdrawal, transfer. In the function space, you'd have a function for deposit, a function for withdrawal, a function for transfer. So they do one thing only, and they have one entry point. So they have input, some compute, possibly some output, or possibly some side effects. So maybe your function puts something into a storage bucket, or it sends an email, or whatever it does, but it does one thing, okay? So that means that your application is essentially, or the application you're deploying are a collection of these functions, all independent. And the advantages, there's all kinds of advantages around management, upgrade, and you hear all the stories of like microservices, like microservice story. Like Netflix talks about how they upgrade their services like all the time. Like all during the day, they're replacing microservices. The serverless world has the same advantage, although at a finer grained level. So for you as a developer, this is much easier. Like if you play around with these platforms, you'll see that it's really easy to just deploy some code and it runs. Not like the old days where you start up your Java E app server yourself, right, and then it's on your desktop and deploy code and sort of manage these app servers. It's really just deploy your code to a cloud service. And these things scale automatically. And I'll talk about this a bit more, but you don't have to worry about scaling. You just deploy your code, and if people call it a lot, well, the platform's going to handle taking care of the load for you. And these are small. So rather than the 10,000 line program that you're compiling, you're waiting for the link to happen, all that kind of stuff, these are small, and I'll show you some small programs. I mean, often they're 10, 20 lines of code, usually pretty small because they do one thing, right? So rather than having, again, the microservice doing 12 things, it's doing one thing only. So from a developer perspective, you can look at your code, you can code review it with your colleagues, you can debug it much more easily because it has one focus. And what's really interesting that I think that a lot of people focus on, which maybe not the most important thing, is that these platforms are pay-as-you-go. So unlike if I deploy a container to a container platform where I will begin paying the provider the moment that container is deployed or that microservice is deployed, right? The clock is on, the thing's it's listening on port 80 or 80, whatever, it's actually burning compute cycles, you're paying for that. In the serverless space or in the function space, you only pay when the function is called. So you can deploy 1,000 functions and you're only being charged when someone's actually calling it. So someone makes a call, the clock starts, it it does some compute, it produces an output, or it updates some storage bucket again. It returns, the clock is stopped, and you're paying just for that time you're using it. So that's really different. So the economics are quite interesting. It means that if you have a very should call it, peaky or spiky kind of workloads where you have lots and then nothing happens for a long time, then you do lots more. This kind of model is quite nice because you're not paying for that idle time, right? The idle time where you handle the peak. So this brings me to the hockey stick. So I'm Canadian, so I have a hockey stick metaphor. Actually, to tell the truth, my colleague who's English actually made the diagram, and I'm like, this is perfect. So here's my story, okay? So explaining why the way this works and why it's a good thing. So let's say you build an Instagram filter type of thing. And we've been doing this actually at the conference. We actually have a demo where we're taking images of people on their phone, take a snapshot of the person, we do some image recognition, we put on a sombrero on their heads, and post the picture back. So it's kind of fun to show your friends, right? So a little function that does some image processing. So let's say you built this for your kids, and this is all kind of fun, right? So maybe it puts puppy dog ears on the picture, so it's cute. So they see this on their phones or on their home computer, and they go to school and they tell their friends about it, and they start using it, right? So you have this increase in usage. It spreads around the school, the kids in the other grades, upper grades are using it, and then the teenagers get their hands on it, and someone posts it to Reddit, and it's like, this is the greatest thing ever, everyone's calling it, and I get this spike, right? I hit this inflection point. So on a serverless platform, if you're a developer, you don't really care. Right? You care about the cost. It'll cost you some money because people's calling your function. But from a developer's perspective, I've written a function that has some input, an image, it produces another image as an output. I'm not worried about inter-process communication, any of these kind of concurrency issues. I have a simple thing that I can have 1 or 1,000. And it's the platform's problem to make sure there are enough functions running to handle the incoming load. So this is a curve which most companies spend their entire year worrying about. Like if you're Macy's or someone and you're worried about Black Friday, that curve is Black Friday. Right? And that's all you spend your time worrying about. In a serverless world, this is not your problem, this is the platform provider's problem. So there's a huge advantage there. So let me give you the good news, bad news about serverless at this point, or functions, okay? So there's a lot of hype. So here's some headlines. Serverless is eating the stack, and people are freaking out. Woohoo! Like Lambda has stamped deprecated on containers. Containers apparently are dead. Okay, now this is from last year. It might be premature to claim they're dead. Here's another one. Serverless adoption on par with containers. Okay, so who's using containers in their job? Okay, who's using serverless functions? Okay, a couple, but not on par. So I think they may be enthusiastic, right? A bit over the top. And this again is last year, so they're claiming either containers are dead or containers are on par with functions. Here's a quote from Chad Aramura. Well, he actually is quoting some analysts. Chad's on our team. Serverless functions, interest in serverless functions from our customers has ranged from astronomical to outrageous. So there's the people who are reading those articles are talking to the analysts saying, tell me about functions, go talk to the vendors and find out what the heck they've got. This is the hottest thing ever. So everyone's very excited, okay? So unfortunately, I think we're on the hype curve somewhere near the top, okay? Or maybe we're just getting over the top now because it's cooling a little bit. But people are thinking this is the greatest thing ever. It's going to solve all your problems. You saw those headlines, containers, they suck. Serverless functions, they're the way to go. That's not going to last, okay? So people are going to use it. They're going to use it wrong. They're going to not have experience with it. And they're going to say, this sucks. This is the worst thing ever. Why did we ever do this? We should go back to what we did before. But really the world, it's like every other tool. This is another tool in your toolkit. It's another way to deploy your code. People will figure out how to use them properly. It'll just become, another thing in your toolkit for productivity, right? So you'll have a mixed world: containers, functions, microservices. I'm sure some large Java E apps that do some back-end business processing they haven't done for years. That's where the world's going to go, right? So right now we're in the freaking out hype time. Don't get caught up in the hype. So that brings me over to Java. So where's Java in all this space? Well, here's the RedMonk Java or language rankings, which you probably are familiar with. Every year it comes out and everyone's kind of keen to look at your favorite language, right? So there's a lot of languages on there. If I zoom in on Java, it's right in there, which is like good, right? So Java is like, wow, one of the most popular languages in the world. It's like maybe 1 or 2. You always see JavaScript, Java these days are contending for the top spots. It's up there, right? So that's great. It's a world domination language, right? except in the function space, this isn't the case. So there's a number of different people taking some measurements of use of different languages in the function space. So New Relic, who have some insight into what people are deploying through their monitoring, they had a number of 9.1% of applications using Java 8 in this case. That's not great. That doesn't seem like world domination. Serverless.com has a couple surveys, a couple of different numbers from them here. This is the more updated numbers from 2018. They had a number of 6.1. So you can see the center is focused on Go. The article was like, how is Go doing? But I turned the graphic and focused on the Java part. But Java is actually pretty close to Go. Go, in fact, has exceeded Java in their numbers in the last year. It's a little bit better in larger companies. So larger companies, enterprise companies, over 1,000, you see Java usage rise to around 15%. So it's not bad. Node you see here is pretty dominant. Python's quite popular too. And then a few more numbers here this is from serverless.com again. This is the trends. The trend isn't good for Java. If you look, it's pretty flat. Like, it's not like Java's taken off. Python increased, see Python 3 goes up, Python 2 goes down, it kind of makes sense. Node surprisingly decreasing, Go increasing at a good pace, and Java kind of flat. So as Java developers, the question is, why aren't people using Java for these things? Like, what's wrong with these? Why is it there? Is it Java just wrong? Is it the wrong language for this environment? Is it because there's some limitations with Java? That's the key question I want to talk about today. So serverless, or Java in the serverless space started with Lambda support, Amazon Lambda support about 2015. So that's about 3 years. So there's quite a while since Java's been available on sort of the first mover platform, right? The first big platform out there. But Python and Node are more popular. And the question is, why is that the case? Is it because people view these small programs in the cloud, these little functions, kind of like scripts, like little web scripts, like knock one off and just toss it in the cloud? Like, do I need Java for that? Is that too much? Is it because Java developers are not used to working with cloud platforms in this way? They're not used to building small little applications. Like even Java is a scripting language, right? You can now get Java, the shell on your desktop. You can do it, right? But people don't do it that much. So we're not thinking this way, perhaps, as Java developers. One of the key ones that gets brought up is the JVM is just not right for short-lived applications. It's just not it doesn't have the right architecture, design, and performance. So these are all good questions. My hope is that, like this article from James Governor, as he says, when web companies grow up, they turn into Java shops. You have all these companies who start off with Ruby and whatnot, and when they want to scale, they want to get performance, they want to tune the heck out of this thing, they want to go to a platform like the JVM, the JDK, which has like amazing performance properties and can be tuned. So when you grow up, when you go to the web, you become a Java shop. The question is, when you grow up in the function space, do you become a Java shop? Right? Is that possible? Or will Node, Python continue to dominate this space? So I think there's some criteria for like what would Java need to do to be a good language for Java, for functions. Key is, I think people want to write plain old Java. They don't want to have to learn some new weird frameworks. They want to write just Java, right? So why should you have to contort yourself to use a new platform, right? Should be just Java. We all have our favorite tools. Like, we all have our religious wars about what's the best build tools, right? So it should just work with whatever tools. It's just Java, hopefully. I want to be able to build complicated applications. So I've talked before about functions are simple little things, but when you have a whole bunch of them, how do you build applications out of those things, right? I need to compose them together. And I need to have a Java application. A Java function has to have low latency, like start up fast, run fast, and return results fast. It has to be a fast experience. It can't be slow. And I'll talk about some of the reasons why it could be slow and some of the things that have been done to change that. And this is a lot of is the JVM suitable kind of questions. So I work on the FN project. It's open source, Apache 2 licensed. You can go to GitHub. Well, through here, you can go to GitHub and download it and try it out. And we have a lot of support for Java. So I'm going to talk mostly in the context of what I'm doing around the FN project, because we have a lot of control over what you can do. And I'll show you some examples of how you can take control. So it runs everywhere. I'll run on my laptop. We have an Oracle Functions cloud service we're building that's like a managed service version of this. You can run it in your own data center if you want. There's someone who has it running on a Raspberry Pi that they had on blog on Medium. They ported it to the Raspberry Pi, so you can run a cloud on a cluster of Raspberry Pis. But FN has really good support for Java. So we have a lot of Java expertise. I work for Oracle. We should be good at this. And so we have some really good support for it. So in fact, the best support we have for programming languages on FN is for Java. And one of the key things we did, decisions we made, was to make functions Docker containers. So we've built this on a very open model. So you know how the platform works. You understand that functions are packaged as containers. If you know about containers and Docker, you know how they work. You know about registries. So we built on that, and that means that we're optimizing for having fast container usage. Okay, so that helps you. If you're familiar with Docker, you'll see that some of the things we want to see the Java VM be able to do are to address how Docker works, basically. Okay, so let me talk about FN and Java, okay, the combo here. So we have these function developer kits. You don't have to use our little libraries, but we have these kits that help you develop functions easily. So we have Java FTK, we have a Go FTK, we have a Ruby FTK, Python, Node, did I say them all? I don't know. There's five. Five of the most popular languages, we have a function developer kit. The Java one has essentially a library you include in your application, and you ask it to basically handle input-output for you. So it handles sort of the protocol of receiving requests from the FN server, which is going to call your function when someone calls your function. It's going to pass the call in. It's going to handle all the sort of the protocol. We have JUnit testing support. So of course, good Java developers are doing JUnit testing. And we have some build images. So we can actually compile your Java code and then run your Java code all with containers. It's kind of a weird experience because you don't actually have to have Java or Node or Python on your machine, because when you basically build Java, we get an image that has the build tools like Maven. It runs the build in the container and then spits out another container as the output. So it's actually kind of weirdly, it's really cool Docker stuff. It's kind of weird to not actually have it installed on your machine. So what I'll do is to give you context, I'll just give you a demo of what that's like and show you the Java experience and a couple of other features in there. So let me just stop that. And I will go to command line. So we have this FN CLI. So if I just have FN, I've got all kinds of things it can do. And I can do things like, let me just go to the top again so you can see it. So I can say FN init, the runtime is Java, and I'm going to create a function called hello J. Okay, so this is just going to create some boilerplate. You don't have to use this init, but every time I do this, hang on here. Let me just set this. We have, of course, multiple versions of our FDK, and it's 1.0.75. Let's try that again. Oh, sorry, now I've done it here. There's a bug. So this is an actively development. There's a bug here where when it fails to create the function, it still creates a folder, which it should not do. Let's take that out. Okay, let me clear it to the top, and you can see it again. Okay, let's just run this. So init, and you see I've got a folder called hello J. So if I cd into hello J, I've got what looks like a pretty normal Java app. Do a tree on that. You can see I've got a func YAML file, which is our metadata, and I'll show you that. A POM, and it's a Maven project, right? So this is looking pretty normal. If I show you the code for this, so this is really the simplest possible function I think you can write. Well, it could be easier. Hello function, it takes a string as input, and it returns a string as output. Okay, so there's no function weirdness in here, right? This is a pretty dull Java. There's no main, mind you. There's no main here, because our FDK is going to instantiate that class and invoke the function that you've asked it to invoke. And in fact, this is not special. The names aren't special. The func YAML file, our little metadata file, you can declare. Like this is the function. This is the class that has the function, and this is the method that implements that function. So that's your entry point into your application. You can. I'll show you chaining functions together. Yes, and this is the key question of can I build apps out of multiple functions, right? It's a key question. So I'll just run. I'm just going to compile this here or run this. So I'm going to go and I'll turn on the verbose mode so you can see what happens. fn-v build. Okay, and I do that. What are we doing now? Service. Oh, do I have a network? No. Uh-oh, I turned it off. It's okay. Yeah, so as you know, in Docker world, if you don't have a connection to a repository, like Docker Hub and stuff, you're dead. I think I'm good. Okay, let's try that again. Ooh, okay. Okay, so I'm pulling down the function developer kit images, so the build images I need. And I turn on verbose mode, so you can see this is all Docker stuff. If you're used to Docker, this looks like you're doing any normal Docker stuff. In fact, what we're doing behind the scenes is we've actually given your POM, we know your POM is there and your code's there. We built a Docker file that compiles your code, and then it builds a container for you, and then it deletes the Docker file, so it's kind of behind the scenes. So I'm paying the Docker tax here of download. All right. So if you watch, Maven's getting built here. Putting the POM in the image. Oh yes, and then we get to pay. So this is the normal Java experience of waiting for Maven to download the internet also, which is great. Runs the test, everything's good, and just bundles it up. Okay. Oh no, now the test. Test run, so just Maven. So whatever I have in my Maven, so in terms of what's in my function, I can go to the Maven POM and just add libraries, right? So I want libraries in my function. Fine, I go to Maven, add the libraries, and use them. Okay, so I've got here a container, right? It's built a container here for my function. I can deploy it, and I've got a local server running. So I've got over here, I've got the FN server. In fact, I'll stop it just to show you. So I can say FN start. Starts a local server. Again, it's a Docker container with the server and all of its bits, so we're very Docker-centric, but it's running locally. And I can run on the cloud, or I can point local machine here. Oops, let's see here. Okay, so wrong one. FN deploy. I'll give it an app. We'll call it code1 co, and I want to say local. So I don't want to push to Docker Hub. I'm just going to work on my local machine. Deployed. I can say ls the apps. I've got an app called co, and I can say fn ls the functions of the co application, and there's my function, hello J. So I can invoke it. The CO application and hello J, right? So it just calls it. So that's pretty boringly easy, which is kind of our goal, right? Our goal is simple stuff should work. That's a pretty easy user experience for the first person. So for a Java developer, that code is not particularly strange looking. The tests also look like normal JUnit tests. So I have a JUnit test here was generated for me. I can create an instance of a function invocation. I can put some parameters on it. I can invoke the function. I can get the results back and do some assertions, right? Stuff you would normally expect to do. What's interesting about this is that, if I go back to the other class here. So as I said, it takes string as input and returns string as input, but it's actually more sophisticated than that. This is the base case. The FTK, the Java FTK, will introspect the signature of your function and understand what you want to receive as input. So I've got one here built with a slightly more complicated inputs and outputs. It's hello world again. Oh, this is my test, I think. Let me take you back to my function here. Okay, so here's a little function. It's got a couple of static classes, an input class, these little pojos, right? Input, output. So this function takes a pojo. And so by default, if our FTK sees that your function is going to take a pojo, it goes, okay, by default, we assume that you're going to pass in JSON. We're going to use Jackson to marshal it into that object for you. We'll call your function. We'll take the result pojo. We'll then use Jackson to unmarshal it and send the JSON back out. It's very defaulty, intelligent default. You can, of course, use Jackson annotations to shape the JSON. And you can even swap out Jackson with anything else you like. It's very pluggable. But what I'm getting at is, it looks very simple Java, but there's actually some power around what the FTK is doing to make your code very simple for you, right? So again, the serverless model should be that the infrastructure is taking care of your problems. And we're trying to do that also for the developer experience. I'll show you one more thing because my colleague David wrote this code up. Kotlin, if you like Kotlin, we have support for the JVM. So once you have the JVM, you can run other JVM languages like Kotlin. So here's a hello world with Kotlin, right? And also, basically, JUnit tests with Kotlin also runs exactly the same, right? It's a Maven build, builds a container. So the JVM actually is a great platform for having this polyglot experience. All right, I'm going to go back over here. Actually, hang on a second here.
If you invoke the function, do you get back some kind of callback URL where you can verify the function is running, or do you have to wait for the function to wait?
So the question is when I invoke a function, do I get a callback handle and I check it, or do I wait? In the current model, you're waiting. It's a synchronous function. We did have asynchronous functions implemented, and we've kind of deferred that. And we're going to come back to that feature. Right now we're working on kind of a fire and forget model instead, which is more of a invoke the function, I don't want to wait. And it's good for integrating with event services where an event occurs, you want to invoke a function, and the event, like Kafka, doesn't want to wait. You just want to fire it off. And then that function will probably do something else that causes a side effect that comes back to you. But there's no, right now there's no async where you get a handle back.
And for example, with different languages like Python, do you have those?
Yes, Python, Ruby, Node, Go, and Java are the current core languages.
But the functionality.
No, so all the languages are the same. So from the functions platform's perspective, it doesn't even know what's in the container. So there's a contract between the FN server and these function containers. They have a certain protocol. What's inside, the server doesn't know. So that's what's nice about this. Extensibility is easy because the service, the runtime, doesn't care about the design time or compile time language. All right. So in terms of my, like, what's good? Oh, we've lost network. We've lost screen. Okay, hang on. Yeah, okay, we're good. So in terms of Java being suitable for functions, so you saw plain old Java deployed as a function. That's good. I used Visual Studio Code with Maven. I can do whatever I want. It's Maven, right? So I can bring up NetBeans and use NetBeans, no problem. Eclipse, I can use that, no problem, right? Because it's just Maven. So now we'll get on to the question you're asking about building complicated applications. So this is a challenge. And in fact, the serverless function community is sort of dealing with this problem. This is where they're at, right? It's like, how do I build apps out of these things? It's great to have a bunch of event handlers that do something when an event happens, but how do I build complex logic? So we have a thing called Flow. And actually, unfortunately, you missed it. David had a session on Tuesday, I think, deep diving into Flow. So I'll just give you the overview of Flow. You can, of course, go and try it. So Flow is orchestration, right? Function orchestration. So I'm going to show you an example, make it more concrete for you. So we have an example that we call Vista. Vista goes off to Flickr. It pulls a bunch of car images with license plates. And we showed this at Java 1 a couple of years ago, but it's a nice example of how Flow works. It pulls license plates. There's a function that goes and looks at the license plate, the photo, and looks for the license plate, finds the license plate. We have another function that will actually draw on the image, like highlight, as you see here, highlight in an output image where that license plate is. And then imagine you're the police, you're looking for a car, so it's watching these, it's taking pictures, finds a car, and then it could like send it off to some like police dispatch, right? In our case, we send it to Slack, because of course, I'm sure the police use Slack. And Twitter to post about, hey, we saw a picture. So this is what we're doing for this demo, or this example. And so Flow, what's interesting about Flow is designed to support these multiple, like composing multiple functions together. Right? So we want to build, again, a scalable, elastic kind of platform for this. And one of the key principles of Flow, or design goals for Flow, was to let you describe algorithms for these applications in code. Right? So if you're a Java developer and you want to write an algorithm, but I call this function, that one, and if an exception occurs, go over here, that's code, rather than something like a YAML or an XML config file, which you see commonly. Right? So we think that having language semantics for describing your flow makes a lot of sense. These are distributed applications, right? So every function that I talk about is running in its own container in the compute fabric that your platform is managing. So this is inherently a distributed computing problem, although it doesn't look exactly like one, right? It looks a little bit cleaner. But Flow has primitives to let you fan out, fan in. So run a bunch of functions concurrently, and then wait for the results of all of them, come back together, or run them in sequence. It has all that kind of stuff. Now, we didn't start from scratch on this. So is anyone using like completion stage or the completable features API? No? Okay, so it came in, It came in Java 8. It's to a couple people. Okay, good, because it's not the most well-known framework, but it's for basically managing threads. It's managing threads through using promises or futures. So you can basically say, I want to execute a piece of code, and I want to get a handle to the result of that, the future result. It's a handle that holds the place where the result will be once that thread's complete. So we work with people like Brian Getz to come up with an API for Flow that looks just like completable futures, except with a couple of extra extensions on a couple of methods. Unfortunately, completable future is not an extensible API. It's one and done. So we look just like, if you know completable futures, you can use Flow. It has the same look and feel. But instead of managing threads, you're managing functions running, again, across a compute fabric. So what that looks like is, here's my example of, from Vista. So I have a scraper function that goes to Flickr, grabs some images. It's going to basically spawn up a whole bunch of functions. For every image we get, we're going to go looking for the license plate, right? Just like do all that. Then for each of those, I want to draw on where the license plate is, assuming it's found, and then I want to blog about it, right? I want to post about it. So that's sort of my algorithm. And so I can use the primitives of Completable Future or the Flow API to describe the algorithm. You know, do one of these, two of these, and then all of those things, right? So this is typical sort of compose semantics here. And when complete, do something else. So what we do is we just take all that and we create a function, a single function that says, this is my algorithm, do this, do that. When something goes wrong, go over here. It's just code. So let's see if you can see this. This is a bit edited down for fitting on a slide. But if you look at the top, we create we have a mouse here? I do have a mouse. So we go off and get the current flow, which is just a handle on sort of this execution flow we're in here. I invoke the scraper function. I then say I want to invoke detect plates. And then you notice there's a lambda expression here that says from detect plates, when that's done, then go and draw the result on the next function. And then down here I have, and then when all that's done, I want to do all of these things. I want to invoke Twitter and I want to invoke Slack. So I'm basically doing both in parallel. And down here I have this construct, when complete. So when all that is done, all that work is done, at the end I want to say, well, did it all work out or not? And if it did, I'm going to say yes, and if not, I'll complain, right? So it's a demo. But I have really rich primitives here for controlling this algorithm. So we have an experimental API for Flow. This is a snapshot of Vista running. So you'll see that when we went off and we said, okay, go to Flickr, get some images, and then you see a bunch of functions concurrently spun up, right, to handle each of those, the processing. So you'll see that each one, and in fact, in this UI, it's very cool. You can click on the execution. You can look at the stack. How did I get there? If it goes wrong, and going wrong is more fun. When it goes wrong, you can click on a bubble and see the exceptions. You can see how did I get there on the flow chain of function, stack dump. Right, so it's really cool, a cool little thing. It's experimental, so it works great, but it's a little bit, it doesn't look slick, right? It's an open source project. We're working on it, One more thing to say about this, just before I move on, because there's lots more cool stuff here. This is Flow without me explicitly invoking functions, right? So it turns out Lambda expressions are serializable. They can be serializable, which means that in Flow we can do things like, down the bottom here, go get the current flow, and then I say, okay, give me a value, I'm going to multiply it by 2, and then I'm going to basically return a string saying your number is this result. These Lambda expressions can be run as functions. We can automatically take a given Lambda, serialize it, and run it concurrently on another compute node. So this is a very powerful way to basically take what looks like a normal Java application and actually leverage more cores, right, concurrently. I wouldn't do it with this. I wouldn't do ×2 as a function, but you get the idea, right? So this is really interesting, and it's very native Java. So this is, again, that experience that we really want to have a native Java experience for composing your applications. Okay, so there's the third sample, right? So we've got through plain Java. It's just Java stuff. I can use my tools, favorite tools. I can build complicated applications. Now let's look at this problem of latency. This is probably the biggest one that I think is probably discouraging people from using Java. So we're putting Java applications in containers. So that kind of changes the problem, right? The problem is, how do I get my Java containerized app to boot fast, right? Run fast. And so what we want is a couple things. We want the Java application or the JVM to respect the constraints of being in a container. There's been some fixes around this, but in the past, if the JVM, if you asked it how much memory do I have, it would tell you how much memory the host has. Right? That was not a good experience, because then you'd allocate a heap that was way too big and then nothing crashes. So that's an issue. Starting fast, of course, like I say, because everyone says, well, Node boots really fast, and small images, and I'll talk about why. Good news is the JDK team are very busy, right? There's a lot of work around container friendliness. So things like making sure that you can find the right processes, right? So using JCMD, you can go off and find the right processes. They're in the container. These things are fixed in 11. That one's fixed in 11. Things around Linux attachment. The container metrics is a new one also. The last one has just come in 11, which is interesting. Being able to run your application with no garbage collection. So this is it seems odd. We talked with this team for many years now for cloud and Java, but there's cases where you want to run a Java app maybe a function. It runs for a few milliseconds, 100 milliseconds, and it's dead. Why would you spend time spinning up threads for garbage collectors? Why would you spend time, right? Run the darn thing, let it just use heap, and then die. So this is a new feature. It's experimental still, but this is the kind of stuff that's going on. They're pretty active in the JDK team on container friendliness, right? There's a lot of work going on, so that's good news. In terms of, that's respecting the constraints, right? In terms of fast startup, there's a whole bunch of techniques. So who's used class data sharing? Okay, no one. So I'd never use it either, so to be honest, right? I've been on a desktop or on a server, and I'm not totally worried about fast application startup in the past. Now it's like a big concern. So class data sharing, apparently it's been in there since 2004. So it's a really old feature. Again, if you're on a desktop, you're not thinking about it. When the JVM starts up, it has to parse through all the JDK classes. It goes through and basically reads bytecodes, builds in memory structures, and then starts loading your code and doing the same thing. With class data sharing, you can basically at sort of build time, do all that parsing in advance, and then you dump an archive. You have an archive, basically a binary format of the JDK classes. So they're pre-compiled to a degree, right? So you're saving time. So when your class boots, when your JVM boots, it doesn't have to do a lot, or you've eliminated a whole bunch of processing that would normally happen that can increase the performance of your app start time. The second thing is they did extend that to application code. So you can take your application code and you can have it pre-parsed, right? So you can run the JVM, there's commands for this, go through and basically dump out my app and the JDK classes as an archive so that when we boot the JVM, it boots that much faster. So these are really nice features, which I don't think, I mean, I haven't used them because, again, it wasn't a concern. Now this is a big issue, right? The bad news is the output is the post-parsed output takes up space. So you saw I had a constraint, I want small images. Well, I can get faster boot time at the expense of fatter, slower, or bigger images. So there's a space-speed trade-off like in life at all times, right? It's always some sort of trade-off. And then the idea of AOT compilation. There's some experimental AOT compilation. We can compile your code into an SO, a shared library that can be linked later. And I'm going to talk about that a bit more. I think that's the most interesting thing because it doesn't come with the space problem. It gives you a speed if you AOT compile your code into machine code, but it doesn't necessarily bulk out, create a large image. So small container images, what do I want to do? Why do I want to do this, right? Well, if you know Docker, you know that if I want to run a Docker container on a given machine, it's a clean machine, to run a container on that platform, I have to bring the container image over there and run it up, start it up. So I have to transfer bits across the network. So a small image moves faster, right? So 15 meg is a lot faster to transfer to a bare machine than 400 meg. That's the start, right? And we're talking about hundreds of milliseconds that we care about here, so this is a big issue. And then Docker itself, it turns out when Docker takes your Docker container image and boots up, it does a bunch of work. It sets up file systems, so copy and write caches, the overlay file system. The more layers you have in your Docker container, the slower it is to boot that container image. So we want to get small containers with very few layers that are very simple. So small is good. That's the bottom line. Small is good. So in Java, you've got a couple of options today, right? So you have JLink. Anyone using JLink? No? The JDK team are going to be so sad if I report back. So JLink, we'll talk about that. Smaller base image, so start with Docker images that are small, and then Substrate, and I'll get to Substrate, the Graal stuff, and that's really exciting. So JLink will go and rip out all the classes you don't need for your app. It works with modules, but also works without modules. So if you see here, the base Java application you can run takes about, well, the JDK classes are 568 meg of code. Of classes that you don't need all of them to run your basic hello world, like it's about 46 meg. Right, so it's a fraction of the size that you actually need in your Java app. But when you deploy an app, you're shipping like all this code on with your JVM. You can run Netty, simple web server, at about 60 meg. So you can get rid of 500 meg of code and still run a basic web server. So why are we packaging up all those 50 meg or 500 meg of classes in my containers? Not a good idea. So JLink can help. Sorry? Only works with modules?
How does that play with modules?
No, it does work with modules. So it's good. It's best with modules, but it also works on without modules. But it'll go through and do a transitive closure. It'll walk your classes, right? So it's slower. What's that? Sorry. Oh, I think that's in 9 and up, right? Yeah, 9 and up. And that's another thing, right? So these features come, and you saw some are in 11. Oh, I have to hurry up and give you this demo. So this one just says, hey, we should use small images like Alpine, right? And they're actually porting the JVM. Technically, it's a port to Alpine to run with the muscle C, libc. So that's a good idea too, is don't go get Ubuntu, right, for this case. But let's talk about Graal. So who's heard about Graal, the GraalVM? Yeah, okay, so this is exciting stuff. It goes and takes your Java application, compiles it down to a native binary with basically a garbage collector, right? So it's machine code plus a garbage collector, that's your app. And makes small images, and it also eliminates a bunch of overhead. So because there's no incremental compilation, you don't have code caches and all kinds of things that the normal hotspot JVM introduces. So it's got less of a footprint in terms of what it needs for running. And I didn't mention before that typically in the functions platforms you use, or you're paying for the amount of memory you're using over time. So if your app needs a lot of memory, it costs a bit more. So having small memory footprint is actually advantageous for cost-wise. So let me just demo Graal. So we have Graal support in FN. And this is actually very new. So we got a pull request from the Graal team recently. It's been merged in. And if I can just get out of here, I can show you. So let's jump over here. Okay. So I actually I'll show you the script here. I wrote, or actually I'll just run it here. If I run a FN init with the SVM, the substrate VM stuff here, and it'll just echo the command. So it says init, image, and we have some support for pluggable initialization, like boilerplate. So create a function, hello SVM. Okay, and it turns out that this code, the hello world code, is identical, right? So we're taking the exact same piece of Java code, the hello world code as a sample. Okay, so this is using substrate VM. So I'm going to take this. Now, I think that, let's see here, if I do fn verbose build, it's going to build that for me. Now, hopefully we'll see this. Oh, see, I got to go. The problem is Docker is just too darn smart about caching. So let me just break this or make a change to my code. So you can see the full experience of what it takes to build. Because you get the normal hotspot build or Delabassee build, and then they run native code generator. And that one does take a little bit of time. So normal things, oh, great. Do I have network? There are test failures. Oh, yes. Okay, don't change your output to get, just add a space. Okay, lesson learned. Okay, do it again. Yeah, my test failed. So hey, see, it's like normal Java, Java stuff. My test failed because I expected one exclamation mark. Okay, so this is normal stuff we saw before, but then we'll get to the last line here, where it's here, native image. Now this takes a bit longer. So you're paying up front, right? You're paying for the compile up front. It's walking through, what Graal's doing here is walking through your Java application from the entry point, doing the transitive closure, finding all the classes you need. It can't find things that you're loading reflectively. And so actually in our case, since we have reflectively invoked the function entry point, we actually have to tell Graal, hey, that's the code you need to keep. Like that entry point is necessary. But it's going through here, analyzing everything and compiling. Okay, it's parsing, building. So the good news is this is going to produce a very small binary. Bad news is you're paying now. So I think in the future, you might see people working with Hotspot in development. It's fast, it's easy. It's good for like the code test, cycle. And then when you're moving on to I'm moving towards production, I'm going to start using Graal to maybe build the final product. Okay, so there's the same. So there it's built here. I'm going to just show you the Docker image sizes. Okay, so this is me. I've done a couple of versions. This is the Graal version, hello. It's about 15 meg for that hello world example. And this is the one we did before, which is about 400 meg. Now this is naive, right? That's worst case, 400. But that's a huge difference by default. It's the same. So deploy. The app is still the code, and and this is local again. Okay, so hello SVM. And so here's an interesting thing. So let's just run that other function for a second. I'm going to run time fn invoke. And this is all running on my laptop. It's not exactly scientific, right? Invoke the thing and hello J. So this is our hello. This is cold. My machine's been idle for a while. Had to get the container started up. 1.17. If I call it again, it's really fast, right? Because the function is running. That's the plain Java one. If I run the other one now, the Graal one. So that one started in about 791 milliseconds, and the Java one, the plain Java, was that. Now, if I call it again, it's going to be fast. They're both fast. Now they're both fast because they're both up and running. But on my crappy laptop, basically I halved it, and sometimes it's about a third. So that little container image with the Graal boots really fast. So, I take any complicated application, compile it on a machine code. That's a really cool thing. Okay, so we're almost out of time. So let's go back to here and finish up. So we're back. Okay, so we basically covered the bases, right? I think that given what the developments in the Java space, Java is a really good language for doing functions in. We know it. If you already know it, great. You can use your favorite tools. The support for deploying these apps, anything on the JVM will run for example, on FN with Java. And with things like Graal, we're getting to the point where we can build very small targeted executables, right, that really are suitable for this space. So I think that, even though the numbers were not good, right, in terms of usage, I think that as things like Graal, App CDS, all the things we can use to build good Java apps, we will see some advantages, some gain in terms of the function usage space. All right, well, that's all the time I have. Thanks very much. I don't know if we can take questions, maybe afterwards. Thanks.